Okay, so first of all, we have circles in geometry and trigonometry. Let's do hard questions from this PDF. So first of all, you've asked about question number 1 from this. Okay, the circle above has center O and the length of arc ADC, that is 5 pi. So this length is 5 pi. And x equals 100. What's the length of the arc ABC? Okay, that's the arc that we're talking about. ABC, what's the length of that arc? X is 100. So what's the remaining angle? 260. So you just do 260 divided by 360 multiplied by 2 pi r. But that's going to be difficult to do because we don't have radius right now. So let's find the radius first of all. ADC arc is 5 pi. Okay. So 5 pi should equal 100 over 360 into 2 pi r. What's the radius that we get from this? Pi and pi get cancelled. What do we get? 9. Okay, so you do this calculation and you get 9 from this, and then you just do 260 over 360 into 2 pi into 9, and that should give you that arc length. What's that? 13 pi. So that's your answer. Another way to think about this could be you could subtract 5 pi from 2 pi r, right? 2 pi r would be 18 pi, 18 pi minus 5 pi, and you would also get 13 pi from this. You still have to do this part, but alternative to this could be 2 pi r minus 5 pi. That also gives the same thing. The angle given is in degrees. So if you have the degrees, angle given in degrees, you use this formula. If the angle is given in radians, you use the radian formula. So it depends on the angle that's given in the question. Okay, the next one is question number 2 from this. The equation above defines a circle in the xy plane. What are the coordinates of the center of the circle? Now, the standard way of finding the center of the circle is completing the square and then comparing with that form, right? But if you're only looking for the center, you can directly do this. If you have the expanded form of a circle, you can find the center's coordinates directly by dividing the x coordinate by -2 and also dividing the y coordinate, I'm sorry, not the x coordinate, the coefficient of x by -2 and the coefficient of y by -2, and that gives you -10 and -8. The center's coordinate should be this. So if you have this form given, this is a direct way of doing this. Whatever is the coefficient of x, divide that by -2. Whatever is the coefficient of y, divide that by -2. And that is going to give you the coordinates of the center. Okay? Radius ke liye, you will have to do that. You'll have to complete the square and then compare with the standard form, which is x minus a whole squared plus y minus b whole squared equals r squared. The alternative to that was that you just put this equation in Desmos and look at what the radius is from Desmos. Right? You get a circle from there. उससे आप देख लें center क्या आता है. Yes, Roma. When you complete the square for this, you get x plus 10 whole squared. When you do that whole process, when you complete the square, you get x plus 10 whole square plus y plus 8 whole square equal to something when you do this. Then you equate this to 0. You get x equal to -10 from that. Equate this to 0, you get y equal to -8 from that. So essentially what you're doing is you're dividing this number by 2 and changing the sign. So changing sign means that you can just divide by -2. So sign automatically change ho jayega. Okay. So in order to find the center, you can just remember this. Divide the coefficient of x by -2, divide the coefficient of y by -2. If it's in the expanded form. If it's in the standard form, from this form, it's obvious that this is -10 and -8. Okay. But if you had to find the radius, you would have had to convert it to the standard form first and then write down the radius. The alternative was using Desmos. Okay, we looked at how to do that when we did circles. Let me move on to the next one, question number 8 from this. Okay, so this is the next one. A circle has center O and points R and S lie on the circle. In triangle ORS, the measure ROS is 88 degrees. What's the measure of RS 1 degrees? Now, it makes things easier if you just draw a rough sketch of this situation. Sorry. This was question 8, right? Okay. It will make things easier if you draw a rough sketch. So let's say this is a circle. Now, what are they saying? R and S are 2 points that lie on the circle. If this is the center, let's say this is R and this is S somewhere, this angle ROS they are saying is 88 degrees. Okay, that's the information that we're given. What's the measure of angle RSO in degrees? So you're looking for this angle. Okay, now it's an isosceles triangle. This is radius, so these base angles have to be equal. So all we have to do is 180 minus 88, that's the remaining angle. Divide this by 2, and that will give you one of those angles, that's 92 over 2, which is 46 degrees. So that's our answer. It said disregard the degree symbol. So when you write this in the fill-in question as a fill-in question, you would say it's just 46. Yes, Roma. Pura kaun sa? Angle is always measured from a straight line. It's not measured from an arc like this. तो straight line बनाएगा ना उससे, arc से तो angle नहीं होगा. Okay. All right. Next is 11. Okay, a circle has center O, and the points A and B lie on the circle. The measure of arc AB is 45 degrees, and the length of arc AB is 3 inches. What's the circumference of the circle in inches? Again, I would prefer that you draw a quick sketch of this. That will make it easier to understand. So you have a circle, center is O, there's a point A on the circle, and there's a point B on the circle. The angle is 45 degrees, this angle is 45 degrees. Length of arc AB, so this arc is 3 inches. What's the circumference of the circle? Circumference is the complete angle of the circle, right? You can use ratios here as well. 45 degrees is 3 inches. What about 360 degrees? What should that be? Let's call that x. So you get x equal to 3 into 360 divided by 45, and you get a result. Okay, you can use simple ratios for this. 360 into 3 divided by 45, that should give you 24. So this is 24D. Okay. Alternatively, you could find the radius first and then use 2 pi r, and that will give you the same thing, 24. Okay. That was 11. Now the last one from this PDF is 16. Okay, a circle in the xy plane has this equation. Which of the following points does not lie in the interior of the circle? Okay, now you have a circle. It has its center at, what's the center? Minus 3, 1. And the radius is 5, right? That's the standard form, x minus a whole squared plus y minus b whole squared equals r squared. So the radius is 5. Now you have a circle like this. You have a circle like this. The center of the circle is at minus 3, 1, and the radius of the circle is 5 units. Any point that is less than 5 units away from minus 3, 1 lies inside the circle. Any point that is equal to 5 units, that lies on the circumference, and any point that's more than 5 units from minus 3, 1, that lies outside the circle. Okay, now just looking at the points, let's see if we can figure this out. -7 and 3, we can't be sure about that. -3, 1, this does lie in the interior because this is the center, right? 0, 0. 0, 0 is 3 units to the right, and then, okay, so 0, 0 would be on the right side, 3 units, and then 1 unit down. So it has to be inside the circle as well. So this is also not correct. 3, 2. 3, 2 means 6 units to the right and 1 unit up. So if you go 6 units to the right from this, you're already outside the circle. -3 से 3 पे जा रहे हैं, that's 6 units. That's already more than 5 units. So you're already outside the circle. It doesn't matter if you go up or down from this, you're outside the circle. So this point has to be outside the circle. So there's no need to find all distances individually. You can just try to think of this like this. Okay. That was last one. I think एक person और मैंने देखा था दरम्यान में, and we'll try to find the radius of the circle. Right? मुश्किल लग रहा है देख के. What's the value of C? All you have to do is write down the equation, simplify that. You have the center, you have the radius. You can write down the equation. The equation would be x plus 5 whole squared plus y minus 2 whole squared equals 81. Simplify the left hand side as well. The constant from this is going to be 25. The constant from this is going to be 4. And from the other side, you have minus 81. This is going to be C. Okay? So that's 29 minus 81, whatever that number is. Yeah. In the xy plane, this graph is a circle. What's the radius of the circle? How do you find this radius? You have to complete the square. Now, if you don't like doing that, what was the alternative? Plot this on Desmos. So this is where Desmos can be helpful. If you don't want to complete the square for this, it might be a bit complicated, especially in this case, because you have a coefficient of x square here, a coefficient of y square. Completing square might be slightly tricky. Okay. So what you do in this case is put this on Desmos. Okay. So what's the equation? 2x squared minus 6x plus 2y squared plus 2y equals 45. And that's your circle. Okay. Do you know the center of the circle? Do you know the center of the circle? Divide x coordinate by 2 and change the sign. Sorry, the coefficient of x by 2 and change the sign. What do you get from that? The center of the circle has to be minus 6 over minus 2. That is 3. X coordinate is 3. 2 over minus 2. The y coordinate is 1. Minus 1, sorry. This is the center of the circle, 3 minus 1. So on this diagram, 3 minus 1 is here. Is that correct? Doesn't look correct. 2x squared minus 6x plus 2y squared plus 2y is the equation that we input here, correct? Equal 45, that's fine. Oh, this is not the center. So you have to be careful in this as well. You cannot do it directly like this. Remember, in the standard form, you have just x squared and just y squared. You have 2x squared and 2y squared here. So you first of all have to divide the whole thing by 2 to make it x squared minus 3x plus y squared plus y equal 45 over 2. And now you can find the center by dividing this coefficient by minus 2, minus 3 over minus 2, that's 1.5. And dividing this coefficient by minus 2, which is 1 over minus 2, which is minus 0.5. 1.5 and minus 0.5, that's the center of the circle. 1.5 and minus 0.5, that will be somewhere around here. Okay, I can't mark that here. Let me see what I can do. Okay. 1.5 and minus 0.5, it is going to be somewhere around here. This is the center of the circle. Okay? That's the center of the circle. Now from this, you can see what the approximate radius is because you have options given there. What's the approximate radius? Let's go to the left. What's this point? This is minus 3.5. And the center's x coordinate was 1.5. So what's the radius then? Minus 3.5 to 1.5? The radius is 5 units. So it has to be A for that reason. Okay? Yes, sir. Nine. If so, this is one way to do it using this pass. The other way would be to complete the square for this because you want that form x minus a whole square and y minus b whole square. You have to complete the square. How would that work? X square minus 3x, y square plus y equals 45 over 2. Add half of 3, which is 3 over 2. Square that and also subtract that, minus 3 over 2 whole squared. Similarly here, add 1 over 2 squared, subtract 1 over 2 squared. And now you get x minus 3 over 2 whole square from this and y plus 1 over 2 whole square from the other one. The constants are minus 9 over 4 and minus 1 over 4. On the other side, you have 45 over 2. You have to take these constants to the other side now. 45 over 2 plus 1 over 4 plus 9 over 4. You have to evaluate that number. That will give you 25. And then you take square root of that. That will be 5. But that's much longer. In some cases, it's not that long. In this case, it was long because you have fractions involved. It becomes complicated as well. So Desmos is helpful for that reason. Okay? All right, so that was circles. Let's move on to the next one. The next one is lines, angles, and triangles. Okay, so this is the next PDF. Let's do hard questions from this as well. Lines, angles, and triangles. So first of all, we have question number 3 from this PDF. Intersecting lines R, S, and T are shown below. What's the value of X? Okay, so the lines are intersecting. What that means is this is 23. We know this is 106. What about this remaining angle? 180 minus 106, that's 74. What's this angle then? 180 minus 74 minus 23? 83. And then this would be 180 minus 83. That's 97. And that's our answer. Right? It wasn't that difficult? Okay, so that was question 3. The next is 5 from this. Okay, in triangle ABC, the measure of angle B is 90 degrees and BD is an altitude of the triangle. Okay, the length AB is 50 and the length of AC is 23 greater than the length of AB. What's the value of BC over BD? Okay, again, it will be easier if you draw a triangle here. BD is an altitude, that means B should be there. Okay, so let's make a triangle like this. Let's say we have a triangle like this. This is B, this is A, this is C. BD is an altitude of the triangle. What that means is, we know this angle is 90. That's one thing that's given. Angle B is 90. BD is an altitude of the triangle. That means there's another 90 here. This is D. Altitude is perpendicular. So BD is perpendicular. So if you make a line from B to the third side, it should be perpendicular to that side. So your altitude at BD. Okay. You could make this triangle differently as well. So you might say, okay, it's a right angle triangle. What if you drew this triangle like this instead? That's also perfectly okay. So if you make the triangle like this instead, this is a right angle. You say this is A, B, C. Now the altitude from B to D would be like this, right? So you can draw the triangle anywhere you want. So this is what the triangle might be. Okay. इस तरह भी बना सकते हैं. Now the length of AB is 15. Okay, this length is 15. And the length of AC is 23 greater than the length of AB. What's that? 23 plus 15? 38. So AC is 38. This complete length is 38. BC over B. What's BC first of all? You can use Pythagoras. BC is equal to square root of 38 square minus 15 square. What's this? 30? This समझ आ रहा है? Sure. Okay. 38 squared minus 15 squared. And then square root of that. That is in decimals. Okay. 34.91. Let's actually keep this in that form. Square this. 1219. So this is square root of 1219. Okay. Now, what about BD? Can we find BD now? BD find कर सकते हैं कैसे तरह BD. Okay, so one way that I can think of is using the area of the triangle. Remember, what's the area of triangle? Half into base into height. So you can find the area of the triangle like this, half into 15 into square root of 1219. Does that make sense? Considering this as the base and this is the height. That's one way to find the area. It's a right angle triangle. Another way to find the area of the triangle could be that you say, let's consider this side as the base, AC as the base. In that case, BD will be the height if you take that side as the base. अगर हम वो base लेते हैं तो BD height होगी, and this would give us 1 over 2 into 38 into BD. And that should give us the length BD. But since we're looking for BD over BC anyway, what's BC? BC is this. So we can actually just do it without finding BC as well. We could say this is BC. And then find BC over BD directly from that. So this working was kind of not required. What I'm doing is I'm saying, let's find the area of the triangle using these as base and height. That's half into 15 into BC. Okay. And then find the area using this as the base and this is the height. That's half into 38 into BD. Since we do not really want the actual values of BC and BD and just need the ratio, we get BC over BD equal to 1 over 2 and 1 over 2 get cancelled, and that's 38 over 15, and that should be D. We could find the actual values as well if we wanted, but they did not ask us for that. Just asked us for this ratio, and this is how you could do that, using areas of triangles. Is that okay? So in order to find area of a triangle, you can take any side as the base, as long as the height that you take is perpendicular to that. So on the right side here, we're taking this as the base and this is the height. That also gives us the area of the triangle. Any problems? No? That was question 5 from this. Okay, so the next one is 8. In triangle RST, angle T is a right angle, point L lies. So that's a lot of information. Let's just draw this triangle. इसके ऊपर साथ साथ हम mention करते जाते हैं फिर. This is a right angle. T is a right angle, and let's say this is R and this is S. Point L lies on RS, point K lies on ST, and LK is parallel to RT. What's the length of KT in units? Okay. Point L lies on RS. So there's a point L on RS somewhere. Let's mark it here for now. Let's say this is L. K lies in ST. So there's a point K here. LK is parallel to RT. Okay, so LK has to be vertical as well. So it's a vertical line like this. Okay, it's parallel to RT. So these sides are parallel. If the length of RT is 7 units, 72 units, this is 72, and the length of LK is 24 units, and the area of the triangle RST is 792. What's the length of KT? Length of KT, that's this length, in units. Okay. What's the length of KT? Once you've drawn this figure, it becomes obvious to you these are similar triangles, right? The smaller triangle and the bigger triangle, these are similar triangles. And you have the area of the triangles given. Can you use that somehow to find the length of KT? Let's use similarity of triangles. That says A1 over A2 should equal L1 over L2 whole squared, right? Let's call the area of the smaller triangle A1 LKS, this triangle, let's call this triangle 1. So iska area kya aayega? A1 over 792. Let's take a corresponding side for this, 24. 24 over 72 whole squared. And that will give us A1, area of the smaller triangle. Is that okay? This gives us 1 over 3, so 1 over 9, so you'll get 792 divided by 9, and that's 88. That's the area of the smaller triangle. Okay? That's the area of the smaller triangle. Once you have this, the area of the smaller triangle, now you need the length KT. अब वो कैसे आ सकती है? You can find the length ST and then the smaller length as well. Okay, so I just thought of a quicker way of doing this. So I'll just get rid of this. So this could work, okay, but you could do it quicker than this. How would you do that? You have the area of the bigger triangle given. Can you use that? Can you use that, the area of the bigger triangle, to find ST? Half into base into height, right? So we can say half into ST multiplied by 72. That equals 792. We can find ST from that. 792 divided by 72 into 2, that's 36. This is going to turn out to be 22. This length is 22. Okay? So using the area of the bigger triangle, we found the length ST. Now we know these are similar triangles. If this length is 22, can we find out the smaller length? What's the ratio? 72 to 24. That's 1 to 3 ratio. So that will be 1 over 3 of that. So KS therefore is going to be 22 over 3. You can use ratios like this. You can say KS over 24 should equal 22 over 72. Okay, and that should give you 22 over 3. And then what is TK or KT? This is 22 over 3. This KT length will be 22 minus 22 over 3, and that should give you 40, 44 over 3, and that is your final answer. That is a bit time taking, so it should be amongst the last few questions on the module, which you should have enough time for. You should aim of doing the first 15 questions and in the first 10 minutes, so that you have 20 to 25 minutes for the last 7 questions. That should be your targeting, and that should be your target in your practice tests as well. So आप बाकी 5 tests करेंगे उनमें भी. You should keep this in mind. Try to do the first 15 questions in maximum 15 minutes, ideally in about 10 minutes, so that you have 20 to 25 minutes for the last 7 questions, because they are time taking and you want some time at the end to recheck your work as well, and hopefully that should work. वो भी सही है. I just thought of a quicker way of doing that. वो भी कर सकते हैं. उससे आपके पास area आएगा of a smaller triangle. Once you have the area of the smaller triangle, you will find this length from that. That's 22 over 3. And then 22 minus 22 over 3. That will give you this as well. So I just figured out that we could do it quicker this way. Okay. All right. So that's question 8 from this PDF, and that's it. All right. So that was lines, angles, and triangles. Let's move on. We should be done before 5, inshallah. All right, so the next PDF is right triangles and trigonometry. Now for this, you need to remember something. The special triangles thing that we did. Remember that? Special triangles. One special triangle was the 90, 45, 45 triangle. In these triangles, lengths are in these ratios. If this is 1, then this is under root 2. Remember this ratio, 1, 1 under root 2. And the other special triangle was 30, 60, 90 triangle. If this is 30, this is 60, and this is 90, if the smallest side, which should have been the other way around by the way, let's say this is 60, and this is 30. If the smallest side is 1, hypotenuse is going to be 2, and this side is going to be under root 3. Okay? You need to remember these ratios. You can do everything without these as well, but this makes things much, much quicker if you remember these these special triangles. So 1, 1 under root 2 means if this is x, this is x, this is x under root 2. Similarly here, if this is x, this is 2x, and this is x under root 3. That's the ratio that you've got. Okay? All right, now let's begin with this. From this PDF, you've asked about questions 4, 5, 7, and 10. Okay, let's start with question number 4. The perimeter of an equilateral triangle is 624. The height of this triangle is k under root 3, where k is a constant. What's the value of k? Okay, it's an equilateral triangle. Equilateral triangle is in which all angles are 60 degrees and all sides are equal. This is what the triangle looks like. Height of this triangle is k under root 3. What they're saying is, if you break down the triangle like this is 90 degrees. This height is what? K under root 3. It was an equilateral triangle. That means this angle is 60. And this is going to be half of 60 now, which is 30. And now you see this is a special triangle. 60, 30, 90. What was the ratio in this? The smaller side, if this is 1, this is 2, and this is 1 times under root 3. So if you say this is k, this is 2k, and this is k under root 3. That's the ratio. Okay? Perimeter is 624. Perimeter of equilateral triangle. So this is 2k, this is also 2k, this is also 2k. What that means is 6k equals 624 and k equals 624 over 6. You can see what that is. 104. That's the value of k that we get. Okay? Any problems? Now, again, you could use it, you could do it without remembering these ratios as well. उसके लिए फिर आपको calculator पे trigonometry use करनी पड़ेगी. You can do that, but this makes it slightly quicker if you remember these ratios. Okay, that was question 4 from this PDF. The next one is 5. Okay, in the figure above, tan B equals 3 over 4. Tan B equals 3 over 4. And if BC is 15 and DA is 4, what's the length of DE? Okay, let's just mark those lengths. We know this angle's tan. BC is 15, BC. This whole length is 15. Okay. DA, this length is 4 units. What's the length of DE? This is what we are looking for. Okay. Tan B is 3 over 4. What's tan? How is tan defined? Opposite over adjacent. So tan of B is 3 over 4. If we look at this smaller triangle, the smaller triangle is triangle BDE, right? In that smaller triangle, we can say if the perpendicular was 3, if the opposite was 3, the adjacent would be 4. Does that make sense? If tan B is equal to 3 over 4, that means this is the opposite and this is adjacent. The ratio between opposite and adjacent, that should be 3 to 4. So if this is 3, this should be 4. And if these are 3 and 4, what about this? This should be 5. That's the ratio of the sides in this triangle. That's what this ratio is telling you. Is that okay? इस पूरे triangle में, these are the ratios, both for the smaller triangle and the bigger triangle. So if you look at the smaller triangle first, do you have any length in that? No. In the bigger triangle, you have this complete length. Now using ratios, if this complete length is 15 and the ratio is 3, 4, 5, divide this by 5, that's 3. 3 times 3, this perpendicular, this vertical length should be 12. Sorry, 4, yeah. This should be 12 and this length should be 9 using those ratios. Okay? Okay, now we know this much. This complete length is 12. If this is 4, that means this remaining length is 8. And again, it's the same ratio here as well. If this is 8, what about DE? Use the same ratios. DE over 8 should be the same as 3 over 4. And DE equals 6 from that. That should be the length of DE. Is that okay? Now, this is a good thing to know about as well. If you have any ratio given, so in this case, you had tan given. If you had any other ratio given, for example, if you had sine of some angle x for some triangle, for some right triangle, and you were given that this is 12 over 13. You can think of a right triangle like this. You can say, okay, in this right triangle, if you're talking about this angle being x, then this is perpendicular, opposite. This is hypotenuse. So if the opposite was 12, the hypotenuse would be 13. Can you find the base from that using Pythagoras? 13 square minus 12 square, square root of that, and that will turn out to be 5. And just this one ratio gives you the ratio between these three sides. These should be the ratios. 5 to 12 to 13. If it's a right angle triangle, the sides of this triangle should be in this ratio. So given any ratio, sine, cos, or tan, you can figure this thing out. This is going to be helpful in your A levels as well, by the way. You will need to do this a lot. ये जो ratios निकाल रहे हैं इस तरह से, but it's helpful here in the SAT problem as well. ठीक है? Okay. That was question 5 from this. The next one is 7. All right. In triangle RST, in triangle RST above, point W, which is not shown, lies on RT. What's the value of cos of RSW minus sine of WST? Okay. W is a point on this line somewhere. Let's say this is W. Now RSW, that is this angle. WST, that is this angle. Let's call this angle X. Let's call this angle Y. Cos of this minus sine of this. What's the relation between these two angles? X plus Y equals 90 degrees. It's a right angle triangle. Remember something about two angles whose sum is 90? Does anyone remember that? हमने कुछ identities की थी. Sine of 90 minus theta is cos theta. Cos of 90 minus theta is sine theta. What that means is if you have any two angles that add up to 90, if you have any two angles that add up to 90, sine of one is cos of the other. If you have, for instance, sine of 50 and you have cos of 40, they will be equal to each other. If you have sine of 75 and you have cos of 15, they will be equal to each other. Any two angles that add up to 90, if you find sine of one, cos of the other, they should be equal. Now, these are two angles that add up to 90. You're finding cos of one, subtracting from that sine of the other. These are supposed to be equal. So the result has to be 0. This difference is 0. Is that okay? So any two angles that add up to 90, sine of one is equal to cos of the other. Okay, so that was question number 7 from this. Next is question 10 from this PDF, the last one from this. Okay, triangle ABC is similar to triangle DEF, where angle A corresponds to angle D, and C and F are right angles. Okay, we have triangle ABC. C and F are right angles. So let's just make those two triangles. Let's say this is one triangle, this is another triangle. Length of AB is 2.9 times the length of D. That means ABC is the bigger triangle. C is the right angle. Let's say this is ABC like this, and the other is DEF like this. These are right angle triangles. Okay. Length of AB is 2.9 times the length of D. So that's the ratio between the two sides. AB over DE, that is 2.9. Similar triangles, we know the ratio of two sides. If tan of A is 21 over 20, okay, tan of A, this is the angle A, its tan is 21 over 20. What that means is the ratio between the sides is like this. If this was 21, this would be 20. Get that? Opposite over adjacent. So tan of A is 21 over 20. That's the ratio between the two sides. What's the value of sine of D? A and D are the same angles. A and D are the same angles. Now, since they are the same angles, are they the same angles? A corresponds to D. Yes, they are the same angles. We can just use this triangle. We actually do not even need the other one. This length is kind of redundant. It's not required. If these two sides are 20 and 21, can you find the hypotenuse? What's AB going to be? Square root of 20 square plus 21 squared, which is 20, 29, the final answer. Square root of that, yes, I have 29. अच्छा ठीक है सही it's all right. I was thinking of something else. ठीक है 20 squared plus 21 squared, square root of that is 29. So this side is 29, so that's the ratio. What's sine of D now? Sine of D is the same thing as sine of A. What's sine of A? Opposite over hypotenuse, which is going to be 21 over 29. And that's your final answer. Opposite over hypotenuse, 21 over 29. Is that okay? That was the last one from this PDF. 21 over 29. This was question number 10 from this. No problems? Okay, now the last PDF that we have is area and volume. Theme. Okay, now let's do the last one. Area and volume, hard questions from this PDF. So there are 3 questions that you've asked from this PDF. Question number 2, first of all. The figure shown is a right circular cylinder. Right circular cylinder, all that means is these are right angles, right? So the base has a right angle like this. This is a right angle. You have R and H. A second cylinder has a volume that is 392 times as the volume of the cylinder. Which of the following could represent the radius R in terms of R, which is small r, and the height H in terms of H of the second cylinder? Okay. So you have a second cylinder and we know something about their volumes, right? Now, what's the volume of the first cylinder? What's the cylinder's volume? Pi r square h. And it's the same for the other one. V equals pi r square h. Okay? Do we treat these as similar figures, by the way? Yes? Both are cylinders. Are any two cylinders similar? Both are right cylinders. Are any two right cylinders similar? No. For 3D figures, the condition for them being similar is all the angles should be equal, and all the sides should be proportional. We do not know if the sides are proportional. Okay, so we are not going to treat them as similar cylinders. All right, so let's find the volume for each one of them. V equals pi r square h and pi r square h. We know that the volume of one of them is 392 times the other. What that means is, if this is 392, this is 1, right? If we divide one by the other, we get pi r square h divided by pi r square h. That equals 392 over 1. Pi and pi get cancelled. And we have r square capital H equal to 392 times small r square into small h. This is what we have. Do we have any other information given? No, that's all the information that we have. Now we'll have to see which one of these satisfies this condition. Okay. Let's just try it in this. R square h. So this gives us 8r whole squared into 7h. Yeah, so what you can actually do is you can just input these in the numerator. R square and h small h are going to get cancelled anyway. This was actually small h. And you would just be left with this number, 8 squared into 7. What's that? 64 times 7. Is that 392? It's not 392? Okay, so this is not 392. Again, the next one that you check is the second one, 8r whole squared into 49h. 8 squared into 49, that's also not correct. And then you do 7 squared into 8. That's 49 into 8. And that you're saying is 392. And that will be correct then. Let's see. Is that okay? That was question 2 from this. The next one is 9. Okay, question number 9. What's the area in square units of the triangle formed by connecting these 3 points? So you have this triangle. This, and this. You want to find the area of this triangle. Now, the first thing that you see in such problems is there any side that is vertical or horizontal? If that was the case, you could use half into base into height. But that's not the case. There's no side that's vertical or horizontal. Now, one idea that you can use here is shoelace formula. Those of you who know that. So that formula x1, y1, x2, y2, x3, y3, and then x1, y1, multiply these three, subtract from these three, you have 1 over 2 outside. That's a long formula. Those of you who know that, you could use that. That's one idea. There's another way to look at this. And that's like this. Make a rectangle like this. Make a rectangle like this. That just inscribes this triangle. The smallest rectangle such that all the vertices, the whole triangle would be inside that triangle, inside that rectangle. Is that okay? So we have this rectangle. Now you can apply this method on all such problems like these. Whenever you have a triangle shown on XY axis like this, make a rectangle like this. Find the area of this rectangle. What's the area of this rectangle? Base into height. Base is minus 3 to 5. That is 8 units. Into height, which is minus 3 to 4. That is 7 units. This is the area of this rectangle. Subtract from this subtract these areas. These are all right angle triangles now. You can subtract the areas from that. Okay. So how do you do that? Minus half. Let's look at this triangle at the bottom first. Half into base. Base of this triangle is minus 3 to 4. That's 7 units. Height is also 7. Subtract this triangle. Half into base, that is 8 units. Into height, that's just 1 unit. Minus half into base of this triangle, the third one, that's just 1. Into height of this triangle, which is 1, 2, 3, 4, 5, 6. And that will give you the area of the triangle in the middle. You can see what that turns out to be. Okay? 24.5. Is that correct? Okay. So that's the result that we get. 24.5. That's the final answer. All right, the last one from this PDF is question 10. A circle A has radius 3n and circle B has radius 129n. Where n is a positive constant, the area of circle B is how many times the area of circle A? area of circle A. What's area given by? Circles are always similar, by the way. Circles are always similar. So you can use similarity if you want. That will also work. So you can say A1 over A2, that equals R1 over R2 whole squared. So area of circle B is how many times the area of circle A. So let's say we are calling B1 and A2. Okay, so A1 over A2, or we could just write it like this to make it simpler. We could say this is AB over area of B over area of A equals RB over RA whole squared of that. Now, what do we get from this? AB over AA, that is RB, radius of B, which is 129n over radius of A, which is 3n whole squared. And you can see what that is. N and n get cancelled. D, 1849. So that's your final answer. Okay? Hajra, is that correct? Verify कर लिया आपने? Okay. 1849. That's the final answer that we have. And that's it. We're done with all the geometry questions as well. Okay. So I hope that was helpful.